Good morning. I think we are going to start now because otherwise we are totally behind time. So I'm very happy to be able to welcome you here to our session on quality assurance and module development. I'm El-Kadhi. I'm the new product owner for the OXID eShop platform, and I'm very happy to be here. Now, why do we need a session for quality assurance? Okay, quite a lot of people are still coming. So I'll just repeat it shortly. Good morning. I'm El-Kadhi, the new product owner for the OXID eShop platform, and I'm very happy to see this session. Well, so many people here, actually. And this session is about quality assurance and module development. Now, why do we need that? Our customers obviously care about their applications, be they the little whiskey store around the corner or a huge multinational company who sells billions of dollars, or rather makes it. They all care about their shops. And the thing about that is that we have, from very small to very big applications that need to work, need to be reliable, need to look great. And so the whole point of that is that we are able to do that with OXID using an ecosystem. So how does our application look? Basically, we have our OXID core. And around that, we have the extensions of our partners. And around that, some customer customization has to be made. Now, all those things talk to each other. And sometimes modules even talk to each other. Now, as I said, the main thing about our platform is that it needs to be reliable. And so what we try to do is to make sure of that by putting a ring of integrity around it, and that is via our certification process, whereby we say, okay, we try to make sure that all our modules, all our components work together, no matter which ones we take. Roland just said we have over 1,500 extensions out there, and making sure that they work together, that one doesn't break the whole system, is one of the core concerns that we have in our development, and then our ecosystem works. And so I'm very, very happy to be able to introduce to you two talks, one by Nordmann, who is trainer and consultant in the PHP world, knows the shop quite well, knows our application quite well. I was glad to be able to join a training of his yesterday, and it was great. And so I'm very, very happy to be able to welcome him here to talk about testing eShops. And after that, of course, after the eShops have been tested, they need to be certified. And for that, our own Rania Tarazi, who is project manager and professional services, will hold a little talk about that. So, over to you.
Yeah, now the first thing I have to do is switching notebooks in a live presentation. This will, of course, break something, but I'll try that. Thank you. Okay, even worked. Thanks. Okay, I'm talking about testing eShops. So what I'm doing is the module certification training to train OXID partners how to be able to certify modules. One major topic there is unit testing, of course, unit testing your modules. Today I'm talking about a different aspect of testing, how to test your full shop in a reliable and sensible way. So first, a little bit about me or my company. I'm a co-founder of Quafoo. We focus on helping people to write high-quality web applications, not only focus on the PHP side or on the OXID side, but also on the JavaScript side. we provide expert consulting, individual trainings to make your developers be able to write better web applications. This is what we are doing. This is a short advertising block. If you need some training, don't hesitate to get in contact with me. I'll be around until tomorrow evening on the Unconference and today at OXID Commons. But let's get to the topic. So how does this development of an OXID eShop actually look like? The first step, of course, always is we have some customer coming to us who has a project idea, who wants to implement some kind of shop with some unique features probably, or some general features, and we want to work on this together. The first thing we always do is some kind of requirements discussion, some kind of requirements engineering. We are discussing topics with our customer. Thank you very much. The topics of the shop with our customers to come up with an idea what the customer actually wants to implement. And you all probably know that your ideas, what the customer wants to have implemented, and the ideas of the customer who requests the shops are probably quite different from the starting point. And the process of agreeing on what to implement can be quite tedious. But yeah, we need to get through that. After that, at least from the point of view of the customer, some magic happens, you are implementing something, and you hopefully end up with an awesome shop at some point. In the meantime, if you're using certified modules, you're forced to, but otherwise I still hope you're writing some unit tests for the software you are developing. So there will be some functions in your modules you really want to ensure that they work in a proper way. So you start writing unit tests for them. So my first question to you, who of you is writing unit tests for your OXID modules? Oh, quite a few, that's nice to see. The next thing you can do is writing front-end tests, like, for example, with Selenium. The easiest way to do that is just record an interaction with your website with some Selenium browser extension, for example, and replaying that. Who of you did that at some point? What were your experiences with that? Some comments? Don't be shy. What was the main problem with Selenium test you experienced?
No, we just have test complete and other software, but I mean, it's the same system, but it's not Selenium.
Okay, so which system did you use?
Test complete.
Test complete, okay. From my experience, those front-end tests you're recording with Selenium have one major issue. The issue is that the customer tends to request changes over time, and Selenium tests, as testing the front end of your shop, tend to break with even small changes. If you're not crafting your Selenium tests really, really well, they even tend to break if you're applying some small CSS change, for example, because some layout bit changes and the tests don't manage to match that form anymore. It depends a little bit on how you write your Selenium tests, but they tend to break a lot. And especially if you change the workflow which is implemented, you need to re-record all those Selenium tests, and this can be horribly annoying. So this is a good way to ensure that your application looks exactly like it looked before, and, for example, works for software producers like OXID really well because their layout rarely changes because they're providing the software behind it. But for a shop with a lot of small iterations in layout, in functionality, Selenium tests tend to break a lot. The next thing which will happen is that your customer might get back, if he was satisfied with your work, he might get back at you 1 year later, half a year later, and wants to add another feature to your shop, the shop you built. Now you got a problem, most likely. Do you always know which features a shop had you implemented 1 year ago? Who of you always knows that? Okay, nobody. A major problem in software development is that requirements we document, of course, change over time. And those requirements tend to be written down in ways which is really, really hard to process and parse for people. So what you could do at this point, reread all those requirements, but I bet most of those requirements are probably not current anymore because some small changes were applied to the shop and changed the requirements, and they are not documented properly. This happens in every software project I, at least, attended. So what can we do about that? I want to talk now about behavior-driven development. The idea behind behavior-driven development is to make the specification executable. So we come up with a specification of the features of a shop and make this specification our test and make this specification executable. This not only works for the shop front end, but also for features in your shop. The idea of behavior-driven development combines the idea of test-driven development, which is common for unit testing, a test-first approach. You write your test and then adapt the implementation to fulfill the test. But where unit testing has a really close technical focus on some specific feature which the customer probably don't even understand, we try to combine a business focus with test-driven development when we talk about behavior-driven development. The main point behind that, and I hope I will be able to show that to you, is that behavior-driven development helps us to find a common language between software development, project owners, customers, and all project shareholders on the specification we need for our software and make that executable. That sounds insane, right? And almost impossible. But the driven development or behavior-driven development means that we come up with a specification, as I mentioned, which is executable, and this changes, again, the development workflow we can establish in our development practice. So let's take a look at this. We have a project shareholder who defines which features we want in our application. This might, for example, be user stories if you're going for some agile feature, or it might be just feature requests. For those feature requests, you define together with your customer, and I'll show you in a bit how this can look like. You describe the features you want, you describe acceptance test, so what does the software need to implement so this feature is fulfilled? And then your common development cycle starts. So your developer receives this feature which is executable, which will fail at this point because you did not implement it yet, of course, and your common development cycle starts. This might be a test-driven way, so you write failing unit test, implement the unit test, you might refactor afterwards, and at some point, after iterating this multiple times, your acceptance test passes. And at this point in time, you know you implemented a feature, and a feature which has been specified between you and the customer together, and the software will be able to check this feature has been implemented. I want to put, before starting to describe how this acceptance test can look like and can work, I want to put the unit tests back into the picture here. If you build a software, this is often compared with building houses, for example. You know those terms, software architecture and stuff like that. So let's try to use this picture here again. A software is usually composed of a lot of parts. Smaller libraries, smaller extensions, you can even boil it down to classes or something. When we are talking about unit tests, we are talking about testing a single unit of code in our software. So we are taking one piece out of our software and analyzing and testing this piece of software. This is what unit tests are about, to ensure that this piece of software works as intended. The problem now with software is that those pieces never work alone. They always interact with other parts of software. And when talking about unit tests, it means, because we just want to test this single bit of software, we need to mock out everything else. So isolate this piece of software from the rest and test it dedicatedly. In complex software, this can be really, really annoying, because depending on how you write software, your single components might have a lot of dependencies in your main system, and then the mocking gets slightly annoying. So what those acceptance tests are is that they are not testing single pieces of code anymore dedicatedly, but try to cover the full software from the front. In this setup, unit tests are slightly losing importance because I'm able now to verify full acceptance criteria for my software. I can verify full features of my software. On the other hand, unit tests are really important for some bits of my software. If I'm writing a library for interacting with some payment provider, for example, I want to really ensure that this library works as it's supposed to be. If I have really complex business logic, I'm probably not able to test it from the full front. I want to be sure that this business logic works exactly as it is supposed to be. If I have code that when this piece of code breaks, I lose a shitload of money, I want to test this code really, really thoroughly. And this is what unit tests are for and will always be for. This is why it makes sense that the certification for OXID modules enforces you to write unit tests. Those extensions are supposed to be, those modules are supposed to be a stable basis for new modules for other applications, for other shops. So you want to make really sure that those modules work as they are supposed to be. But on top of that, we are developing shops. And shops consist of a bunch of modules, but those modules, of course, need to integrate well with each other. And this is what acceptance tests are for in our case. To put this in an even larger picture, to compare those test types, I highlighted unit tests and acceptance tests. Acceptance tests are those behavior-driven tests I'm talking about, and unit tests. So what we have with unit tests are highly stable tests because the code which is unit tested is not supposed to change, like testing a library, for example, which is used by others, testing a module which is used by others. It's not supposed to change. Those tests will likely never break, hopefully. On the other hand, the coverage of unit tests is fairly low. You're testing one unit of code, so you're not testing like large bits of the application at once. On the other hand, we have acceptance tests. Acceptance tests easily test with the first call to your front page of the shop, for example, easily test like 30% of your code because everything is initialized, set up, and most of it is run at once. This means, since a lot of code is touched, that those acceptance tests tend to break. If you change the workflow in a major way, acceptance tests will break. There are mechanisms, I'll mention them, to make those acceptance tests slightly stabler, to make them break less often, but they will break far more often than unit tests. So again, unit tests for really stable and important code, acceptance tests to verify that your acceptance criteria imposed by the project owner, for example, are met for your software. So let me introduce you to Behead. Behead is a part of Cucumber, which comes from the Ruby world and which uses Gherkin as a language to write those acceptance tests in a way that everybody is able to read them, or at least it's the idea behind it. Let's take a direct look at such a test, which we can write with Behead and Gherkin. Remember, the goal is to write something which the business will understand and which the developer is able to interpret and be able to impose on your software. A test can look like this, for example. This is a domain I choose, which is from a random restaurant, a domain you are not familiar with, at least from an implementer's point of view, but a domain you all know from going to a restaurant and ordering a steak. So the idea is, as I said, to come up with multiple scenarios which together define a feature, for example, in your software, and every feature should be able to be understood by everybody, by every stakeholder in your project, developers, project owners, customers, whoever there is. And we want still to be able to interpret this as a developer. Let's take a look at this first scenario, which is I get my steak. First, this is kind of similar from a developer's point of view to unit test. We create our environment. We're doing something like a setup of our environment. We define preconditions for our test, given there are 6 steaks on stock in the restaurant. Then I apply stimulus. This is, again, the same I'm usually doing in tests. When I order a steak and I wait for the waiter. So a simple test stimulus. And at the very end, we have an assertion, then I get a steak. So I can phrase my business test case, which is I get steaks when they are on stock, in a way we can interpret with code. And I'll show you how this works in a bit. There are, of course, ways to write down multiple scenarios, like a second scenario, steak is out of stock, where, if there are 0 steaks on stock and I order steaks and the waiter tells me I have no steaks left. So the idea behind Behead is that we write down natural sentences given a defined structure, we have those preconditions or test setup is given. We have a test stimulus in when, and of course we have some assertions to verify that our acceptance test is met in then. There are ways to combine then with and but take a look at a simple demo for that. So not only doing switching laptops, but also doing a small demo. I hope this is readable at the very back too. Can you please nod if you can read that? Thank you. So what I have now here is an example feature which is even simpler, but it's just an example, so bear with me for a very, very simple example. So we have this feature, dummy datetime example, which just tests the PHP datetime class you might be familiar with or not. It does not really matter because this test case is supposed to be understandable by about anybody. Then we have the scenario, we want to get the end of the month. So what we can write here, and this is entirely up to you, up to us, or up to you, what sentences you are actually using here, is given it's the 1st of February in 2013, when I proceed to the end of the month, then it results in the 28th of February 2013. So this is a custom language you came up to verify that the datetime class of PHP works correctly. I can now execute this example with Behead, which is a tool which we are using here. And the first thing, because I did not define the stuff yet, is what Behead tells me is that we have one undefined scenario which does not yet work. The next thing Behead tells me is those are the method stubs I need to implement in some context to be able to execute this. What you can see here is that we get simple regular expressions in annotations on methods to be able to implement all those sentences. What I, as a developer now, of course, need to do is providing some implementation to make this work. So interact with my application here to make this stuff work. What you also can see is that we had automatically extracted extracted. This is a parameter because it's in quotation marks. We can see this again here, and it by default throws pending exceptions because this test pens to be implemented. What I can do next is implement custom PHP classes to make this feature work. For this, there exists a feature context in Behead where I can import custom contexts. Contexts are everything which interacts with my application. So what I'm doing here is enabling the example context, which I prepared already, which I will show to you now. Those are the methods which Behead suggested me to implement. So we can see the exactly same method stub again, but now with some kind of implementation. And the only thing I need to do in here now, because this is a very simple example, I instantiate datetime if the test is started with I enter date, and then I modify the datetime in the when step, and then I perform an assertion in the then step. I'm reusing PHP unit assertions here. You might be familiar with. Behead itself does not come with its own set of assertions. And since I enabled this test now, I can execute this very simple specification, and Behead tells me everything's fine, datetime works. This is the case if I want to come up with a custom DSL. But when we are talking about websites, it gets even easier. Let me introduce Mink. Mink is supposed to be a web acceptance test framework. And it builds an abstraction layer on top of browser emulators like Selenium, Sahi. Selenium you might be familiar with, but Sahi is very simple. It's, as far as I recall, a fork of Selenium made a little bit more easy to use, basically. Then there's an implementation for Zombie.js, which is a pure JavaScript browser emulator. And there's Good, which is purely PHP side, just requesting websites, not executing JavaScript at all. So we have several browser emulators wrapped in an abstraction layer, which is then called Mink. And then there is a Mink Behead integration. So what we can do now is something like this. I can write down sentences which describe how I interact with my website. Mink just provides, this Mink Behead extension just provides a set of sample sentences. So what I can do now, do I have highlighting here? No, I don't. I can write a simple scenario where I'm searching Wikipedia for my forename. So given I'm on / I'm on the root page of Wikipedia, I am fill in search input with Core, I press the search button, and then I should see a classic Wikipedia redirection site with all the meanings of Core. There are two things here which I want to mention. One I will mention in 2 slides, but the first thing I want to mention is, since you're writing those tests in a fairly manual way and not recording them with Selenium, for example, it's easier to make those tests stable. I'm using IDs here, which are available in the HTML of the Wikipedia front page. And by using those IDs, I can ensure fairly well that this test will not break even with small layout changes or even with larger layout changes, because the input box just needs to have this ID and the submit button just needs to have the ID search button. That's everything I need here. I have a second test which does not matter that much here right now. So we have a set of sentences which makes it possible to test a website. But if you look at this example again, you could complain about one thing. Would your customer be able to write this? Probably not, or he at least would not like to write this. But we can combine both things I mentioned. So what we transfer this example to is something slightly different. I transfer this example to, given I'm on the front page, I search for Core, and then I should see Core may refer to. This is something everybody can still understand, but we can reuse all those Mink sentences in a very simple way. What Behead would now do again is what I showed you earlier. It would show me, okay, I don't know this sentence, please implement this sentence. And then I can go and write code for this by reusing those Mink sentences I mentioned we had on 2 slides earlier. And I can just execute a bunch of steps for this custom sentence. And it's really easy for me as a developer to come up with those sentences for some assertion a project owner or customer makes. I can even have multiple steps combined in one single step. So the sentence I search for something translates to the Mink steps I fill in search input with the search term and I press the search button. An additional nice thing is that the sentence I search for will probably never change because this stays in my domain. But the implementation of the step can, of course, change and be adapted if the developer knows I need to change my HTML, for example. So, let me execute that test. Please don't use the internet for a moment because I'm executing this test live on Wikipedia. So I'm testing the BDD variant, and let's start with the other variant first and check if it works sanely. So what I'm using in this example is the good browser emulator, which just executes some PHP. This means it's fairly fast, but if there would be JavaScript required to execute those tests, it would just not work. But what we can see here is that those tests are executed. It's not that fast because, yeah, I'm accessing Wikipedia through an overcrowded wireless LAN. And of course, those acceptance tests will always be kind of slow because they're executing your full website. So if your website takes to load a little bit, you will notice it here. What I did with the other test case, let me open that first. I annotated those features with add JavaScript, which tells Behead those tests, or the Behead Mink combination, those tests require JavaScript to work. We know they don't, but for illustration, I'll keep it this way. So we tell those tests we need JavaScript to work. What we can do now is configure in some global configuration file or local configuration file for Behead that please, for the JavaScript session, use a different browser emulator. In this case, Sahi, which I started on a different shell. And what will happen now is that those tests will magically, more or less magically, be executed in some browser. And I hope this works fine. And you see popping up the browser which executes now the exactly same test cases as before. This is, of course, not only useful to ensure that JavaScript works on your website in the way it's supposed to be, but it's also very useful to, for example, test it with different browsers. And you can execute all your acceptance tests with a bunch of browsers you configure, like if you have the correct VMs in place with Internet Explorer and so on. What we can see here is, let me make it a little bit smaller, does not help, is the modified test case I just executed. Given I'm on the front page, I search for some search term, and then I assert on the results. So, there's one more thing I want to mention here. The graphic, the illustration is slightly complex, but let us go through this one. What I did was writing test cases in the context of Behead. Behead just interprets this gherkin DSLs and makes it possible to execute something based on that. What I showed you was those Mink extension sentences which the Mink extension provides me to interact with browsers. What I also showed you was a datetime extension I came up with myself, which are custom extensions to interact with whatever you wrote. And now the idea is that the Mink extension uses all those browser emulators like Good and Sahi to access your application front end, going on the front side of your application and making assertions on the HTML, on the JavaScript, which defines your shop. But my custom extensions can at the same time access the backend of my shop or whatever I like, because I can execute any PHP code I like. So what I can do here is resetting the database, inserting some fixtures in my shop, or doing whatever you can imagine. So the combination of two, the being able to test the front end and executing custom PHP code to modify about anything in your shop you're supposed to test, is a very, very nice way to ensure it works exactly the way you want it to work. And yeah, of course, those feature tests are executed, parsed and executed, and we get a nice result from that. I showed you the most verbose output of Behead. There are other outputs which work better in like continuous integration systems and stuff like that, where you get better reportings from, but the basic idea should be clear. To summarize this, Behead, the main point behind Behead is that we establish a new communication tool where we can agree on features with all project shareholders. Writing those Behead tests will always involve all the project shareholders. You will sit together with the developer, with the customer at one table, discuss those features and specify them down to the last word. The problem in most projects is that there are slightly different interpretations of some terms, and different people have different meanings associated with some terms. When writing down those sentences together with your customer, you will find out about the problems in your term definitions between all stakeholders. And you'll establish sentences which all agree on. If you're a developer, the nice thing for you is that you can, like half a year later, point the customer to some feature you came up with and say, we defined it this way, not the way you think we defined it today. So you have some persistent, executable documentation and specification of your project. And this specification and this documentation will always be valid for your project because you execute it all the time. There's no outdated documentation in here. There can be the point that you want to delete a feature, but this is of course fine, but then, because it defines then, my feature is outdated and the customer does not want this feature anymore. Especially if you're doing some agile development, features will tend to change, and this means that those stories you encode in those acceptance tests will be deleted at some point, and you, of course, also want to manage those deletion of features, modification of features in a sane way. But this is a different talk and a different perspective on this topic. I want to reiterate one point. Unit tests are still really important. For the really important bits of your code where maximum stability is required, please write unit tests. Those feature acceptance tests will never cover your full code and your application. It will ensure that the business use cases will work, but there are always side cases which we will not manage to test with those tests. So please still use unit tests for all the important bits, for the really stable parts. But the acceptance tests with frameworks like Behead serve a very good ground or very good basis for discussing features with your customer and making sure those features work as they are supposed to be in the long term. So this is this. Thank you.
Thank you, Cole. I think we really need to think about those parts of checking our modules also with Behead, because obviously they also have requirements that we need to discuss with customers, because that's why we do them. But coming back to maximum stability, unit testing, we still need to do that in order to ensure that our extensions work together. And for that, we have a certification process. A few words Rania will talk to us about. As I said, Rania is a member of our professional services team and responsible for the module certification of the OXID eShop platform.
Thank you. I think you have to prepare the slides, I guess. It's too late to say good morning. Hello, everybody. It's already almost 11 o'clock. Thank you, Cora, for your detailed inside view into software quality. I'll have a short session on the topic module certification procedure. My name is Rania Tarazi. I work at OXID eSales since last year, so this is my jubileum, my year one in May. And I work as a project manager in the professional services department. And I'll try if this works here. There we go. Yeah, perfect. Based on the technical unit tests and code reviews that Corey just emphasized in his session, the OXID module certification guarantees high quality of code. So what are the advantages of certified modules? First of all, within OXID Exchange, it's I guess all of you know what OXID Exchange is. It's an international online marketplace for extensions. Certified modules are clearly visible by a seal of quality. You see the seal on this slide here in a large view. So they are highlighted by this seal within OXID Exchange platform. Furthermore, you achieve a better software quality by attaining better software compatibility and better maintainability. And therefore, you have a better reliance for users and for your customers. And that's one of the main arguments, last but least, that the customer satisfaction increases. So, on this slide, I'll talk about a little about the process of module certification. As I said, to ensure module maintainability, code quality, and software design are inspected according to OXID's standards. And so you probably will ask, what are the steps for a successful OXID certification, module certification? So first of all, first step would be to develop your OXID module with the help of our tutorials. And the second step is to log in and download the free certification package and inform yourself about the criteria of OXID module certification, as well as the pricing and the technical structure. Third point would be the submission itself. So what do? You submit your modules, you submit your tests with your modules, and the installation structures to our email module certification at oxidesales.com. And the last step is that we will review your module based on the OXID eShop module certification rules. And during this review process, you will receive according feedback, and the findings we send you by email in our feedback have to be incorporated into your module. So it's a communication process between OXID and you as a module producer. And after the findings have been incorporated into your modules and we do a rechecking of your module, OXID approves everything, and your tested module will at the end receive a official OXID seal. So this is more or less the process to submit your module and to receive a certification of your module. Are there any questions to the process? Is anybody in here that already has done this process or not yet? I don't know. Any module producer? No? Not yet? Sure.
To have the seal that it is OXID approved,
Yes.
does it have to be on the marketplace, or can I have it like somewhere else and just copy the seal, the image?
This is a good question. I spontaneously can't answer. I mean, we would prefer to have it on OXID Exchange. I don't see any disadvantages for you.
No, but let's say I have it on GitHub, it's open source,
Yeah.
it's certified, and can I take the image, which is also on the Exchange?
I have to clarify it. I don't have an idea about the image and the rights for this image. Do you have an idea, Eric?
I'm not sure, but I would guess it's all right. But let's check first.
It's better to clarify before we...
I want it to be right, okay? Let's take that first.
Yeah, so... Any more questions? No? Oops. Okay. So what does the certification package include? The certification package includes the OXID eSales module certification rules, and there are 4 areas that are examined or that are reviewed. The first would be software tests, so the unit tests that have to be included. The software quality itself, that's the second area. And then the inter-module compatibility, I have problems with this word. And the fourth is the module documentation. The package you download within the login area, it includes a technical structure for you to develop the module and the tests accordingly. And it also includes the module certification table rules with all the conditions. So you can check if your unit tests and your module fulfills the rules, the certification rules that OXID gives as a basis for your development and for your module. So these are the main areas. I don't want to get into the details because it's more or less, the session is about the procedure itself. And from my side, that would be it. So if you have any questions to the module certification, these are the rules. They're included as a PDF document. It's about, I think, 20 pages. You can download it within the certification package, as I said. And that's more or less it concerning module certification procedure. Any questions to the details or to the procedure itself? Not yet. So nobody here in the room who has turned in or submitted a module for certification? I guess not. Nobody's raising their hands. Okay, no questions, then I'm here anytime. If you have detailed questions, we can talk about it in detail. So, then thank you very much.
Thank you, Rania. So thank you all for having join the session. We are all available for further talks, should any further questions be there. And I wish you all a nice Commons, because there's a lot to come.
Yes, thank you.